In the summer of 2009, Taqa Energy initiated a project for 3 subsea well interventions in the Dutch sector of the North Sea. For this, Taqa contracted the Seajax Kraken to host intervention operations. These were carried out by the Well Service Alliance, headed by EXPRO, together with BJ Services and Baker Hughes.
She's a self-propelled jack-up unit. We have our own propulsion system, so we can steam between A and B short distances. It's not designed to go long distances like crossing the Atlantic, but for short distances and moves within oil fields. We are self-propelled, but we have 4 legs which we wind down using a rack and pinion system, and we set them on the seabed and then lift the vessel clear of the water to give the client a stable platform to carry out his operations.
The Seajax Kraken vessel was transported from Halifax, Nova Scotia to Vlissingen by the Dockwise Swan. It arrived late November 2009.
The vessel is now actually in Vlissingen Harbour, and we're here to mobilise for a contract with Taqa to try and recover a well for them. At the moment, we're installing our thrusters, which had to be taken off for our transit across from Canada, where we've been working for the last 6 months. After we finished that, we had to go onto the back of one of Dockwise's heavy lift vessels, the Swan.
Over 14 days, a team of experts carried out a number of project-specific rig modifications and pre-installed all well service equipment on board prior to sailing to the first offshore location. One advantage of the Kraken is that all well service equipment can be installed in port, and it can sail to location fully rigged up. Upon arrival, it is ready to commence operations. The rig moves from port to location and into field were done with the vessel's own propulsion system. The vessel is equipped with 2 pedestal cranes, of which one is a 300-ton crane to support well service operations. The thrusters had to be removed to allow the Kraken to be loaded on the Dockwise Swan in Halifax. On arrival in Vlissingen, the thrusters were then reinstalled. Each was loaded on a tender and positioned below the vessel's hull. They were then hoisted into position and installed.
The final thruster has just been lifted into position. They're just bolting it in place. We are presently preheating the motors, because we have the manufacturers recommend 48 hours heating to get rid of any condensation form coming across on the passage.
The project also required the installation of flare booms on the port and starboard sides of the vessel. To enable this, a boom suspension system or king posts were engineered, fabricated and installed on the Kraken. For final commissioning, the booms were trial fit in port before sailing to location.
The sea trials, we've got to carry them out for our peace of mind as well as the clients, to make sure that everything functions correctly. It's a very sophisticated system, a DP system, so you've got to make sure that when you ask it to move ahead, it moves ahead, and that the reference systems are operational. And also we'll have to check make sure the jacking system is fully functional as well. That will be done when we jack down here, to be honest, and then when we jack back up, we don't see any problems with that, as it's already been proved that it's working okay, but it's always good to check it again just as a final check.
After sea trials, further modifications were made to the vessel to receive a project-specific cantilever deck. This construction would provide a safe working platform for the operation to take place. The hull of the Kraken was strengthened to withstand the forces generated by this construction hanging off the stern. The Subsea project also needed extensive diving and ROV support. A structure to host the diver's launch and recovery system was also constructed on the stern. The ROV launch and recovery system was located on the port side. The next step in the preparation was the installation of the cantilever platform. This had arrived on the quayside in parts and was assembled, awaiting final installation on the Kraken deck. The cantilever deck was designed by EXPRO, with input from all partners interfacing with the construction. Manufacturing was in Den Helder, next to EXPRO's operating base. This was one of the bases that provided operational support to the offshore project.
We're here in the commissioning phase of this cantilever platform that's being purpose-built for a operation for Taqa Energy in Holland. This cantilever platform is going to interface with the Seajax Kraken and is going to provide access to the subsea wells that require well service operations in the North Sea. The platform is built to provide access for coil tubing and wireline operations. It has a movable deck. The deck can be put in 9 positions to center the platform above the well center after the Kraken has been positioned. The platform provides a platform that can take about a 50-ton load to provide support to the coil tubing frames and the wireline operations.
After manufacturing was completed, commissioning ensured all systems fitted and interfaced correctly before final installation. The cantilever was landed on the deck of the Kraken, the construction welded to the deck, and welds inspected. Meanwhile, remaining well service equipment was loaded on board and sea fastened.
Because this as such is not overboard because you stand on water.
After the 15 by 1 meter main beams were installed, the actual work deck was hoisted into position. With the cantilever installed and welds inspected, a final load test was carried out. This proof loading was done using 2 water bags weighing 60 tons. They were attached to a calibrated weight scale hanging off the cantilever deck, simulating the maximum design deck load. The deflection of the platform beams was precisely monitored using laser instruments. The reaction forces from the cantilever construction on the Kraken's deck were measured using a special load cell connected to the EXPRO data acquisition system for permanent monitoring and alarm. After the preparation and commissioning was successfully completed, the Kraken sailed to its first offshore location, mid-December 2009. With all equipment rigged up and sea-fastened on deck, the Kraken sailed from Vlissingen to its first location in the P15 field. The final positioning above the subsea wellhead had to be done very accurately, exactly lining up the wellhead with the cantilever deck. The vessel's dynamic positioning system, with its powerful thrusters, assured accuracy of position at all times.
We're here on the Kraken self-propelled lift vessel, situated over one of the Rhine Charlie P15 of Taqa Energy Netherlands subsea wells with the Well Service Alliance, which is a combination of companies in the well service business contracted by Taqa to do a well intervention on 3 subsea completions in this Rhine Charlie field.
Divers were responsible for the physical connection of the riser to the top of the tree on the seabed. To connect the equipment on the deck of the Kraken to the subsea wellhead, a riser was installed.
The vessel is going to be positioned on 3 subsea completions, and the intention is to clean out one of the wells where we have a lot of wireline in it. It's going to be drilled out with a coil tubing unit, which you see in the background, BJ. And the other 2 wells we're going to close off the water production part of the pay zones in 2 gas production wells.
The actual well intervention starts with a downhole investigation using EXPRO slickline services to establish if the well is clean of debris from the surface to the reservoir. The slickline provides the ability to remove debris plus setting and retrieving of mechanical plugs in the tubing. Slickline was used extensively throughout the project, utilizing EXPRO's combined E-line and slickline unit. BJ Services placed a structure on the cantilever deck to facilitate the coiled tubing operations. The coiled tubing was then further rigged up and the injector head placed on the structure. Coiled tubing was used to clean out the wells to enable the well intervention. Nitrogen and brine are pumped via the coiled tubing to help removing debris from the well. A variety of tools were deployed on the coiled tubing tool string. They were prepared and tested in the tool container. During the first well, extensive milling was done to clear blockages in the tubing. This is a mill returning to surface after such a milling operation. A cement plug was set on top of a mechanical plug in the wellbore. These are preparations for the cementing operation.